What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, Qwik Poland and WorkshopFest.dev. Welcome back to the JavaScript Master Podcast. Today, together with Miško Hevery, who is a CTO at Builder.io, creator of Qwik, Angular, Angular.js and co-creator of Karma.js, we will talk about QWIK City. Hi Miško, how are you?
I am doing well. Thank you for having me again. It is so fun to be here.
Okay, thank you so much. Popularity of this new framework is growing rapidly. What is the status of Qwik today?
Yeah, so I think last we spoke, we really dived into Qwik itself. And just kind of review for listeners, Qwik is, Qwik is to React, like QWIK City is to Next.js, right? So the QWIK City is our meta framework and Qwik is kind of the rendering pipeline. And so last we really talked about Qwik itself, what makes Qwik unique. I think this time around, we should talk about Qwik City. Qwik City is the meta framework that's built on top of Qwik. And I think it's the thing that provides a lot of differentiation. Also, meta frameworks is kind of a status quo these days. Like it's hard for anybody to imagine building a site without a meta framework. So it's a kind of a requirement these days. And I think it's good to kind of jump into it and discuss it.
Okay, so what is Qwik City? What is available in Qwik City that is not available in Qwik itself?
Right. So the Qwik itself is concerned with obviously rendering. This is kind of similar to any other framework you would choose. But I think Qwik is also interested in other parts that are usually not considered part of the rendering pipeline of other frameworks. So let me give you some examples. Qwik is concerned with bundling, with breaking up your application into smaller chunks. It's interested in lazy loading. It's interested in prefetching of the code so that you'll never get in a situation where the user has to wait for the lazy loaded code to kind of load. And I think that kind of makes Qwik kind of unique. Like many of these kind of features or server-side rendering, for example, or serialization of data, those kind of features are usually part of a meta framework in other places, but they're actually part of Qwik itself. What the Qwik City, on the other hand, has is basically directory-based routing. And this is popular, right? It's not anything new. All meta frameworks have directory-based routing. But what actually makes Qwik City interesting is that a lot of other meta frameworks have to solve, how do I solve SSR? How do I solve serialization? How do I solve lazy loading? How do I solve lazy loading on route change and so on and so forth? All of those concerns actually for us are part of the Qwik framework itself, the core, rather than the meta framework on top of it. And so surprisingly, Qwik City itself is surprisingly small. Because most of the heavy lifting of lazy loading, serialization, etc., is actually done by Qwik. So anyway, so you have directory-based routing, you have nested layouts, file-based menus, breadcrumbs, support of MDX and TSX files for creating your content. So in that sense, if you look at it from that point of view, it's very, very similar to what other meta frameworks have. Yeah. So on the end of the day, like the Qwik City is essentially a router, right? And I think there's this common way of separating frameworks that basically talks about MPA versus SPA. And if you think about it, what it comes down to is where exactly is the router, right? For an MPA application, the router is on a server. And for an SPA application, the router is on the client. I think what makes Qwik City kind of unique is that it kind of straddles both. Like it can run both in MPA mode and also in SPA mode. As a matter of fact, it can just transition between these two modes without really saying like this whole thing is an MPA or this whole thing is an SPA. You can very much choose individual pages between MPA or SPA just purely by whether you use a href, right, which is a server-side link, or whether you use a link component, which kind of emulates the href, but actually turns into a client-side navigation and rendering. So Qwik City is kind of interesting in that it's kind of what I think Rich Harris coined transitional, meaning that it is both an MPA and SPA. And as a matter of fact, once you start building applications in Qwik, you don't really think of them as MPA or SPA. It's, I think MPA, SPA kind of difference or the separation grows from the fact that previous frameworks had to make a choice. Do you run on the server or do you run on the client, right? And because Qwik knows how to straddle the two, it can start running on a server and it can transition to running on a client. This MPA, SPA kind of differentiation doesn't make as much of a sense.
How this transition is possible?
Yeah, so Qwik has this interesting property, which is kind of hard to explain because there is no analog in other frameworks. And this unique property that Qwik has is that it can take closures, and it can allocate the closure on server, for example, and continue running the closure on the client. And the opposite is also possible. You can allocate a closure on a client and then run on the server. But it's kind of a strange thing. Like, what do you mean? Like, how can a closure be allocated on one side and then run on the other side? So let me give you an example of this. Let's say you have a page and you want to listen to mouse move event, right? Well, the way you would do this normally is that, like, when you need to set up a listener for the mouse move, and you can't do that on a server. So really you have some code that eagerly executes on the client, and that code that eagerly executes on a client sets up your mouse listener. And when you set up a mouse listener, you really are calling add event listener. And what you need to do is you need to pass in to the add event listener the closure. In other words, you have to eagerly create the function, the closure that will be executed if the mouse moves. And this function has to be created eagerly before you even know whether somebody actually is going to move the mouse or not. You know, for example, if you're on a mobile device, it may very well be that nobody will ever move a mouse because, well, there is no mouse on a mobile, right? You're going to have touch events, not click events, and you're going to have scroll events, not mouse moves events. And so the way we kind of think about it normally is that these closures have to be eagerly created, they have to be allocated, their code has to be present at the time of registering the events, and we just kind of live with it. We just kind of take it for granted. And, you know, for most developers, it will be really obvious, like, well, that code can only run on the client. Where else would you run it? And so it becomes kind of a strange mind bend when you come to a Qwik application and you say, actually, you can execute the registration of event listeners on the server. In other words, on a server, you're going to take a DOM element and say, hey, I want you to have a listener. So in the case of a mouse move, you probably would grab the document and you'd say, document, I want you to have a mouse move listener, and let me allocate the closure that is associated with, you know, the code that I want you to run when the mouse moves, and let me pass that over to the add event listener, right? Now, most people will look at it and say, like, well, yes, but that can't possibly run on the client because, like, you know, how can you do this, right? And this is the magic of Qwik, right? We figured out a way for you to allocate the closure on a server and then serialize all of it in such a way that on the client, you don't actually have to eagerly run the add event listener for the mouse move. Instead, the client wakes up and, you know, we have this thing called the Qwik loader, which is a global listener, which sets it all up. And this global listener kind of sets up a global listening for a mouse move, but it doesn't actually download the code or anything like that, because it knows that it may never happen that you get a mouse move. So until you actually start moving the mouse, until the events actually show up, the associated closure isn't actually, you know, materialized. The closure is materialized lazily once the event actually happens, which is very, very different from a classical way of doing things, right? Because in the classical way of doing things, you have to materialize the closure eagerly before you have it. And so what do we mean by serialization? Well, there's two parts to it, right? We know how to serialize code. Well, that's just JavaScript. We know how to load the code, you know, through imports and dynamic imports, etc. That in itself is not kind of new or surprising or hard. What is kind of new is the fact that, you know, a function is a top-level function that you can import. That's easy. But a closure is more than that. Closure is a function plus a closure closes over some state, right? So let's say you have a mouse move, and let's say the mouse moves depends on a state of the component that where you store the X and Y position of the mouse, right? So it's not just about saying like, oh, execute this code, because the code, when it wakes up, says, well, yes, but I need to go update the state of the component. How do I get a hold of the state of the component, right? And normally the answer is very simple. Well, the closure closes over the state variable, which was declared in the component above. And because it closes over that variable, you get to use it and you get to do whatever you want with it, right? And so the hard part or the magical part out of Qwik is that we can take that closure and we can say, okay, the code part goes into JavaScript. That's easy. And then the variables that you closed over, that has to be serialized as JSON, right? So the two parts kind of move apart, right? One code path is for the JavaScript code, and the other code path is for the data itself. And then when the event actually happens, that's when you put the two parts together. Now, this sounds pretty simple, but it's actually even more complicated than that, because you realize that on a server, you actually have to run different code than on the client, because on a server, you most likely have to run CJS, right? Which means you most likely have to have require statements, not import statements, and so on and so forth. So when you compile for Node.js, even though Node.js kind of does support MGS things, it's not a really good supporter. You really are better off just for now, future, hopefully it's going to change. For now, you're better off using the require. So you have to produce a CJS file for Node. But then if you're in the client, you can't have a CJS file. There you have to have an MJS file, right? So it's this interesting thing where you take the code, you split it up, you compile it one way for the server, another way for the browser, and then reassemble everything in such a way that to you, it's completely seamless, right? To you, all you see is like, oh, I wrote this function, I registered the function during SSR, and yet on the client, when the client runs, I don't have to re-register the listener, right? The listener is just there, and I just continue running. And so this is a pretty kind of a fundamental shift, the way you think about how code runs. The nice part is that it's simple the way we present it to the user. It's very, very straightforward. All we're doing is saying, look, you write a function, just like you would normally write a function, right? Nothing special about it. The only thing you have to do is you have to make sure that the function gets wrapped in a special wrapper, which we call the $, right? That's why you see $signs everywhere in Qwik. And as long as you wrap it around with the $, what the $sign means is that it both tells the developer, like, magic's going to happen here. This particular thing that's in the $, that will do these tricks of like serialization, deserialization, separation, lazy loading, etc. So there's special rules that have to apply over here. But it also tells our internal, what we call the optimizer, to do all of this for you, right? And so the nice thing about it is, you as a developer, you don't have to think about it of like, oh, this is a server code, so I have to put it in server file. This is a client code, so I have to put it in the client. And, oh, how do I refer to these things? Like, I can't just refer from the client to the server function. I have to go through some registry, either a URL or fetch or something that kind of ties the client-side execution to the server-side execution. And then I have to somehow take the type information from the server side and move it to the client side. And, the type information has to be moved separately because the types are okay to import from the server side because they get erased. But the function itself is not okay to import from the client side, because importing it would mean that it would get bundled together, and that's a no-go, because that function, because it's running on the server, probably imports, MongoDB or who knows what, right? You just can't do that. And so as a developer, you don't have to think about it, right? All you have to know is like, oh, this is this boundary. And the way I mark the boundary is I wrap it in a $sign, right? And many of our existing APIs already have the $sign included. So if you're declaring a component, it's component $sign. So this is happening automatically. Where you want to run a task, you say use task $sign, meaning that this will automatically do this trick. If you want to have a click listener, you say on click $sign, or in this particular case, as we're using the example, on mouse move $ equals whatever. And that automatically sets up the listener and does all the magic of lazy loading, etc., for you without really thinking about it.
So if we talk about this $sign, let's talk about the data endpoints like loader, action.
Yes. So one of the big things that you have to do when you're building an application, right, is you have to load data on a server. And so a loader is a way of getting data from the server to the client. But you also want to do the opposite. You want to be able to take the data on the client and push it to the server. And that's what we call an action, right? So the loader is a direction of data flow is server to the client, and an action is client to the server. And typically, an action will have a side effect, right? You're not just giving data to the server. Presumably, you want the server to do something with it, right? I am creating a new issue. So I want you to, make a new issue. So my action is issue create. I'm giving you information about the issue, but like you need to do kind of the work on the other side. You need to have a side effect of storing the data in the database. So those are the two different things. Now, normally when you have that, there are constraints. Right. So you can't just call a function on a server. Right. Because, if you did that, as again, we said earlier, you would be importing the code of the server into the client. And then the bundler wouldn't know that that's not supposed to be done. And so the bundler would include it. And now you would have a problem. First of all, the client side code would get too large. But more importantly, the function, the action function probably talks to a MongoDB. And so now you are including the MongoDB driver in the client, which I'm sure will cause problems when the MongoDB tries to wake up and do its work, right? So you can't just refer to the function. And so a lot of stuff that we do as developers is basically, dancing around this problem that I have a code that I want to run on the server and I have a code that I want to run on the client. And these two codes have to be in separate locations because the bundling system needs to not confuse itself, right? As we said, the bundling system for the server probably has to do CJS, but the bundling system for the client has to do MJS. And so a lot of what we do is just kind of separating this stuff and having these rules about what gets to be, who is allowed to import what and who is allowed to pass what across. And we have a pretty strict kind of separation between this is a client code and this is a server code. And so what Qwik is trying to do is kind of blur these lines. And I can see a lot of people going ooh, blurring the lines. That seems like a horrible thing. Bad things could happen. Valid concern. I would say give a Qwik a try and then see how it actually works in practice. And you're going to discover that it's actually very enjoyable. It's very clear when you're declaring a loader or an action, and therefore you are on the server. And when are you on the client and declaring a component, and therefore components, they can run on the server or they can run on the client. And so just based on the context of where you're putting your code, pretty clearly, okay, this only runs on the server, or this only runs on the client, or this runs in both places. To give you an example, right? If you have an on listener, the piece of code that registers the on listener, so let's look at on click. The on click can execute on a server during SSR or SSG. So that piece of code can execute as part of the server execution. And also it can also execute on the client if you're in SPA mode as well, right? But primarily it will probably execute on a server. But the listener itself, the click listener, right? Will only execute on the client because nobody can click on anything or nobody can mouse move on it or anything on a server. So you can register the events on a server, but the actual event execution, will only happen on a client. And so just purely by context, oh, this is a purely client code. This is a code that could run in both, or this is a code that I know will only run on a server.
You're listening, JavaScript Master Podcast. Listen, code, repeat. Everything you need to know to become an JavaScript super developer.
Now let's talk about the latest data endpoint, server $.
Right. So we started with a loader and actions, and there is an analog in other frameworks. So if you look at Next.js, get server props is very similar to loader $. We think the DX is actually nicer with the loader $, but fundamentally it solves the same problem. I'm not actually familiar if Next.js has something similar to action $. I know Remix has a way of running actions on a server. But in general, you have a problem to solve. Like, let's say you want to run code on a server. So you have this idea of an action, right? And you need a way of attaching the code on the client to the code on the server. And because you can't do a direct import, right? The direct import is not allowed because doing so would bring too much code to the client, as kind of we discussed. There is always some form of indirection. Let's call it a registry. There's always some registry that is involved that knows how to map usually a string on a client to a function on a server, right? Something in there needs to be that basically says like, oh, right, you are trying to execute this function, but you can't refer to it. So I'm going to give it some other name, something, right? And then you can eventually refer to it on the client. And so I don't know the details of how, like, for example, Remix solves this problem, but this problem exists and it needs to be solved somehow. Now, what is unique about actions is that they're fundamentally tied to a form, meaning that they work even if JavaScript is not present. And, Remix makes a big deal out of that. And so, similarly, I think we make kind of a big deal out of it, which is kind of nice that even if JavaScript is not present, the thing works. Not that anybody runs the code without JavaScript, but I think it kind of demonstrates that if the system worked without JavaScript, you're essentially implying that you have SEO solved, right? Because if it runs without JavaScript, then the search engine essentially must see the same thing as the user would have seen had they turned off the JavaScript. And so that's a kind of a good property to have. And so the way it's done in Qwik is that in Qwik, you can directly refer to the function on the server. And the reason why this works is because the action, ends in a $. And a $, what the $, says is this piece of closure, this code, may or may not be loaded or may be lazy loaded or may not even ever load on a client. And all the action $ knows to do is basically say, oh, I'm on a client, therefore I know I cannot directly call this function. I have to go through like a fetch or some other API or form post API. But the syntax is nice because the syntax allows you, the client code, to directly refer to the server-side actions. And so we just released this in the latest version of Qwik, and we're super excited about it. And then we're kind of thinking about it, and we kind of had a realization. And the realization is like, it goes something like this. Actions are fundamentally tied to forms because we want to have this property that even if JavaScript is not present, actions should continue running. And so in that sense, they're really, really nice. But what if you remove the constraint? What if you say, like, actually, let's just assume JavaScript is running on a server, right? Therefore, the action is no longer tied to a form. It's just basically going to become some form of a fetch post mechanism on a client. Well, if you remove that constraint, that means that now any kind of a closure that you wrap in server $, you can call it and invoke it remotely. So let me give you an example. Let's say you have a component, and the component has a button, and that button has an on-click. And inside of the on-click, you say server $, and you pass in the closure that says, talk to a database or something. You end up in this interesting world where the component itself renders on a server because we have SSR, SSG, right? So the component code executes on a server. Then the component code, you push the click button. We know that, event listeners, they always execute in the client because the click can never happen on the server. And so now you're running on the client, and in the client, you go and execute stuff. Now the server $, basically says, take this closure, and we already know how to move closures around because resumability is one of those requirements that we can start executing on a server and move the execution to the client. But the opposite works just as well. We can take a closure from the client and move it back into the server. And so what the server $, does is literally that. It takes the closure that you pass in to the client, and then moves it back to the server and then executes it. What it means is that it grabs the closure's lexical variables that it captured, right? Serializes it, sends to the server. On a server, it needs to load the CGS equivalent, not the MGS code, the CGS equivalent code, merge the two together, and now it has a function that it can execute. And so you can get into this world where you write you've read a component, you create a button inside of the component, the button has an on-click listener. Inside of the on-click listener, you say server $, and you pass in a closure that says console log, hello world. And you get into this world where like the closure, the component executes on a server, the click listener executes on the client, but then it invokes a function back on a server. So the server then prints out the console log on a server. And this makes it super, super easy to kind of move between the two. It becomes very fluid and very natural, right? You basically come to the conclusion of like, oh, I'm building my application. Gee, I need to talk to the server. I need to do something. Normally this is like a big thing. Pause, go create a server endpoint, do a whole bunch of stuff, right? When everything is done, come back and call it, right? Here it's like, oh, I need to do something on a server. Server $, close the parentheses, closure, whatever. And this closure gets to close over any kind of variables that you see in the lexical scope. So for example, if you want to refer to the current name or the current filter value or, what have you inside of it, the system automatically moves that information to the server. So when the closure runs on a server, it has access to those variables. And so the end result is that it's very natural for people to kind of build this and use it. And I think this creates a beautiful DX in the sense that it makes it super easy for people now to build applications and not have these huge points of discontinuity, right, in their mental bookmark or whatever mental model. Whenever they're like, oh, I'm on the client, I need to talk to the server, like it becomes this huge ordeal, create new files, create a mapping, create a URL, define it, right? None of that stuff really applies. And you can just kind of short circuit these things. But because it's running on top of Qwik, you get to serialize everything. You get to, for example, serialize things like, obviously JSON, that's easy. But even more complicated things like date, well, that's not something that normally can be serialized, right? But you can even serialize things like DOM references. Clearly on the server, you can't read the DOM, but you can have a reference. And so you can like pass it around. And for example, you can pass in 2 references of the DOM from the client to the server, and server can decide to return one or the other, and then you'll get the correct DOM reference on the other side back in the client. Obviously, the server can't like interact with the reference. It can't basically say like, give me the inner HTML of it or something like that, but you can work with it. You can even do even crazier things. You can, for example, capture promises and have the promises resolve on the server. And that's kind of a mind blown, right? Like how exactly, if you have a promise that's not yet resolved, and that promise is captured by a function that's now going to run on the server, but that means that now the server will wait until the promise resolves on a client, send over the data, and then continue execution of the server on a client, and then finally return the data. So all of these kinds of use cases become super easy and super powerful. And I think it speaks a lot to just the developer experience you can have.
It sounds amazing.
We think it is,
yeah.
But it's also very hard to explain. It is also like, for example, one person, Manu tweeted this, and one person was like, oh, that sounds like a horrible idea because now you have code injection, right? And I was thinking about it. Why would you have code injection? It makes no sense. And then I realized, oh, I think what they're thinking is that we are taking the function and we're calling a toString on it and literally sending the function like that to the server and of course executing. And that would be a horrible thing because yes, then you have code injection problem, right? But that's not what's happening. Instead, we're just sending the data that the function serializes and the function ID. And then we look up the same function on a server, right? It had to be compiled. It can't just be like pulled out of a thin air. It had to exist at the time of compilation. And then we cross-reference this and find the equivalent function in the CJS land. and then restore its closure and then execute it, right? And so there is no place for injection. You can't just tell the server to execute arbitrary code, because whatever the server will execute, that code had to exist at the time of the compilation. And so it's interesting to see that like people look at it and they're like, that's cool. And they have a whole bunch of assumptions of how it works. And it's like, well, no, that's not actually what's happening under the hood.
To sum up our conversation, can you give us the biggest advantages of using QWIK City?
I think originally we started the Qwik and we focused on time to interactive, the removing of the hydration problem, right? We wanted to make the UX for the developer better. And the big thing we had to figure out was how not to execute code eagerly on the client, right? Because if you kind of look into it, you realize it all comes down to not executing code on the client, right? So Qwik's architecture is really all about how not to execute code. And to get there, you have to solve a particular problem. And the particular problem is you need to be able to serialize closures, right? That's where we started. But now that we have this, we're realizing actually this property, it's nice to have the hydration not happening and the resumability and everything, but this property is actually amazing for DX because it allows you to move execution of the code between the client and a server and do it multiple times back and forth. And I think that is something that really makes the developer experience much, much better, right? So Qwik originally started with this idea of let's make the UX better by executing less code. But in the process of building that infrastructure, we realized it actually makes the developer experience better because we're no longer tying you to either this execution model or that execution model. Instead, it's easy for us to go back and forth between the two execution models.
We have a Qwik, we have a QWIK City, and we have a Party Town. Can you give us an idea of this three division?
Yes. So at the end of the day, the thing that drives us is we want to make the web better. And to us, that particular thing has a very specific connotation. And to us, it really just means make it faster, right? Because if you make the web faster, then everybody's going to use it more, right? And so it all comes down to speed for us. And so there are two and if you kind of explore this speed problem further, you realize it comes down to just the amount of JavaScript you send to the browser, right? So the name of the game is, how do I send less JavaScript? And so you look at, well, where does the JavaScript come from? And it comes from two different parts. It comes from your first party code, right? The application you're writing. And to that, we have an answer, and the answer is Qwik. And it also comes from third party code, right? All of your HubSpot, Google Analytics, Facebook Pixel, and all that stuff, all this stuff that you need. And then, by the way, I think I read somewhere that Google says that on average, a site has something like 20 or so third-party scripts on their page, an average website. So that's a lot of third-party code. And so the purpose of the Party Town is to move this third-party code over to the web worker. Right? Because what we want to do is in order for the for the end user to have a good experience, you need to make sure that the main thread is available to do the user's bidding, right? Whatever user wants to do, that's what the main thread is supposed to do. But instead what's happening is that we're abusing the main thread and we're running a whole bunch of other stuff on the main thread for the stuff that kind of we need to collect and, the analytics and all these other parts. And because we're doing it on the main thread, the user experience suffers. And so by moving the execution from the main thread to the web worker thread, and this is what Party Town does, it knows how to do the movement over, right? By moving it over, we can now make the user experience better because it's less, it's less janky, basically. It has a faster startup, etc. But it all comes back to our goal, our desire to just execute less JavaScript on the main thread, right? All modern all modern phones, they have multiple CPU cores. But as long as your JavaScript is single-threaded, it doesn't matter how many cores you have. You cannot take advantage of them, right? And so part of the goal of Party Town is to make sure that we can easily move code into separate workers, which in other words means separate CPU cores. And oh, by the way, that brings me back to another point is we have this cool, we kind of discussed this idea of a server $sign that allows you to easily move execution back to the server. If you can easily move the execution back to the server, then it also means you can easily move the execution to a web worker. So imagine writing your application and just saying, I really want to run this function in a web worker, and just saying worker $sign and wrap the closure in there. And all of a sudden that closure runs in the web worker, right? You don't have to think about okay, how do I move the code into a separate file? How do I load the file into a web worker? How do I communicate? How do I send data back and forth? How do I await the information of it? None of that stuff is something you have to think about. You just basically say, hey, here is a piece of code I want to run it where? Server, web worker, or, what have you.
How did the name City come about?
It's a play on words. So it all started with Party Town. So because you have third-party scripts, so you can send them to a party town, party town, right? They can party over there. They can do whatever they want. So they don't bother us,
okay.
Right? So that's what Party Town came about. And then we started Qwik, and at some point we realized that Qwik is not enough. Because Qwik is just a rendering framework. People at this point really expect the meta framework to go with Qwik as well. And so in order for Qwik to be successful, we have to build QWIK City. And so when we started working on the Qwik, the meta framework, we needed a name, and we thought, why don't we just continue this town city metaphor? And so we called it QWIK City. Amusingly, the router inside of the QWIK City produces a city plan. That's the list of routes that you need to use, but we call them city plan as well. So it's just purely a play on words.
Miško, thank you for your time. It is always a great pleasure to talk with you. Now, I want to invite our listeners to more episodes starring you. We are planning the next one in just 2 weeks.
I would love to come on your next podcast and chat with you again. It's always a pleasure.
Thank you so much.